is saying, so let's write B. So B is saying the diagram below shows a sketch of the graph of y is equal to 3 minus 2x minus x squared passing through P, Q, and R. So as we can see, this is P, Q, and R. P and R are on the x-axis, meaning since they are on the x-axis, the coordinate of y is 0. Q also is on the y-axis, meaning the x-coordinate is 0. What I mean is, if you find the coordinates of P, the coordinates of P are going to be x, 0. The y-coordinate will always be equal to 0. Same applies to R. It's x, 0. Then this is 0, y, because it is on the y-axis, meaning the x-coordinate is 0. That is, if you were asked to find the coordinates of P, Q, and R, you use that notion that when it is on the x-axis, the value of y is 0. When it is on the y-axis, the value of x is 0. So obviously solve a question where you'll be asked to find the coordinates of P and R or Q. But here what we have is they want us to find, one, the equation of the axis of symmetry of the graph, meaning the line of symmetry of the graph. That is what they want us to find. So what do we do, or what method do we use? So to find the axis of symmetry, so one, we use the formula. The axis of symmetry is given by x is equal to negative b over 2a. Okay, where b and a are coefficients of the terms of this quadratic equation. Now, we know that the standard equation or the standard quadratic equation is given by y is equal to ax squared plus bx plus c. That is the standard equation, meaning the highest power, the coefficient of the highest power is a. The coefficient of the second power is b, and the constant is c. So it's just a matter of recognizing those things from this equation and then replacing them here. So meaning, let us rearrange this equation. So this equation is y is equal to, we start with negative x, okay, followed by minus 2x, and then we have, this is positive, so we're going to say plus 3. Okay, so a is negative 1, b is negative 2, c is 3. So a is equal to negative 1, b is negative 2, and c is positive 3. So once we have those, we can now find the line of symmetry using this formula. So let us proceed and say x. So we're going to write x here. So we're going to say x, that is, now we are finding the line of symmetry. So we're going to say x is equal to, okay, so please pardon me, let me erase that. Okay, so x is going to be negative b. Already in the formula there is a negative, okay, and the value of b is negative, so you put it in brackets like that, over 2, then a is negative 1, which is the negative 1 there. Okay, then therefore the line of symmetry, which is the x coordinate of the turning point, is therefore going to be negative times negative will give us positive, so we have 2 times negative 1, that will give us negative 2. Then negative 2 into positive 2, that will give us negative 1. So meaning the equation of the line of symmetry is going to be x is equal to negative 1. So that is how you find the line of symmetry of a curve. And as you can see, this same formula is the formula that we use to find the value of x of the turning point. The other formula that we can use for the axis or the equation of the line of symmetry is given by, you can also say, where am I going to write it? So let us just proceed to the next page. Okay, so the other way you can find the equation of the line of symmetry is by using this formula. X is equal to x1 plus x2 over 2. Okay, where, so let me go back, where x1 and x2 are the coordinates. So let's so where x1 and x2, where x1 is this one and x2 is this one, the coordinates of P and R, meaning the coordinates of the points that are on the x-axis. That is another formula you can use. So if we had coordinates here and here, we just get the two x coordinates and then replace them in these formulas, x1 and x2. The other way you can do this is by differentiating the equation, because at the symmetry, dy over dx is equal to 0. So meaning you have to differentiate the curve and then equate it to 0, and you are going to find the value of x. We can actually find that. We can actually do that. Okay, so these are the ways through which, or the other ways, you can find the equation of the line of symmetry or the x coordinate of the turning points. Okay, so let us now proceed to question 2, Roman numeral 2. So Roman numeral 2 is saying coordinates of the turning point of the graph. So coordinates of the turning points. So coordinates of the turning points. Now, turning point, we know for it to be a point, it is given by x, y. Okay, now the x coordinate is found using the formula. So the x coordinate, we've seen the formula. You can use this, you can use that, or you can use negative b over 2a. That is how you find the x coordinate. And in this case, we've already found the x coordinate. Now, how do you find the y coordinate? So you can find the y coordinate by using the formula 4ac minus b squared over 2a. 4ac minus b squared over, over 4a, sorry. So over 4a, not 2a, it's 4a. So over 4a. That is the formula for the y coordinate. And we already have a, we have b, we also have c. So it's just a matter of replacing them there. So let us check. So we check from there. We have a is negative 1, b is negative 2, c is 3. So let us see, replace them in our formulas. So as we can see, a is negative 1 from the equation, b is negative 2, and c is 3. So it's just a matter of getting this, the way we had replaced b and a in this formula to find x. That's the same way, or that's the same way you find the y coordinate. So let us do that as well. Okay. So x has already been found. So x has already been found. So x, we found x to be negative 1. Okay, that is straightforward. Okay, then let us find y. So y is therefore going to be 4 AC. A is negative 1, as we saw it. C is 3 minus B is negative 2 squared over 4A, which is negative 1. Okay, then y is therefore going to be 4 times negative 1 times 3, that to give us negative 12. Then minus negative 2 squared, that is going to give us 4, positive 4. In brackets, we are going to have positive 4. So we have positive 4 over 4 times negative 1, that will give us negative 4. Therefore, y is going to be negative 12 minus 4. That is going to give us negative 16 over negative 4. And the value of y is going to be negative 4 into negative 16. That will give us positive 4. Therefore, the coordinates of the turning points, the x coordinate was negative 1 and the y coordinate was positive 4. So that is how you find the coordinates of the turning point. Another way you can find the value of y is, so another formula or another way you can find the value of y is, so another way you can find the value of y is, so I'll just say you are going to get this value of x and then replace it where there is x in the original equation. So according to what we have, the original equation is y is equal to negative 3 minus 2x minus x squared. So you're going to say y is equal to 3 minus 2x minus x squared. So where there is x, you put negative 1. Okay, because that is the value of x. So you say y is equal to 3 minus 2. You open the brackets, negative 1 minus negative 1 squared. Okay? Then you are going to say the value of y will be 3. Negative times negative, that will give us positive 2. Then minus negative 1 squared, that will give us positive 1. And so y is going to be 3 plus 2 plus minus 1, that will give us positive 4. So that is another way you can find the value of y. So this is very simple and very straightforward. Watch this video as many times as you can and share to family and friends, because they say sharing is caring. Thank you very much for your time and God bless you.